Hey Colin, how you doing? We got a question to start off right here. Number 5 on the 475. I had the plots they're asked for, but I don't know how to interpret them. That's a good start. Might be doing some 201 here in a moment too. But if you're in the chat, jump on in. We have the 201 test later today. So number 5, BS 475. If you got questions, say hey. Number 5, doing well. Awesome. Assignment 4, and we just released the stocks assignment. Assignment 4, question 5. Let's go look at those graphics. Doing well. Let's make sure MuBot is awake. And let's do this right here. So let's go take a look at that. Make sure I have everything closed down. Close down this. Close down this. Okay, let's do this. Here we go. Onto the main screen. It's at 1:17. I always take my timestamps. Taking timestamps during the video, it says help me MuBot. Go away, MuBot. He's appearing on the screen right here. We'll give out some points since MuBot's awake. And let's give out some points. It is Wacky Wednesdays. We'll see Crash here in a moment. But if you're in the chat, hey, Brian, how are you doing today? Good job. Good, great. Doing well, Kai. I can't even speak. I'm on cup of coffee number 2. Maybe do 3 today. But today is going well. If you have questions, put them in the chat. I love coding. Frankly, you might think I'm crazy. People might think I've gone mad. But one of my favorite things to do, you'll see me do it in 201, is use code to answer questions. So if we go over here to, I'm going to close it right now, 2 seconds. And then go over here, decomp. Go here to number 5. I love just looking at stuff with code. And it's just such a great way to go through and answer questions and think about what are we learning. So let's look at this one right here. This one says, revisit the Canadian gas data and create an X11 decomp. So what is an X11 decomp? Well, it's just people giving a name to the decomp they're using. Well, we should probably know what a decomp is, right? You might be wondering in 201, what is a decomp? Well, a decomposition is when things are broken apart into their subsequent parts. And Colton right here, what kind of decomps do we have? Like if I take a series, complicated a career mode encoding, I still think it's, oh, yeah, of course, Kaya. 100 points, Kaya. I couldn't agree more. Because this is what's so cool. Watch this. We could have a series like this. And so that's just a series of data, right? And so if you're in 201, you should know a few things right now. So 201, you should say that's a blank. And also we could say that this is let's say it's quarterly data. So this is quarters right here. So you should know this is a what? So Colton, these are quarters. This is the price of something. And you should know a few things of what this is called. So 201 review right here. Correlation, you bet. Jalen, which one do you want to do? Tell me which number and we can go do that next. Here, you got it. But good question for 201 exam right here. This graphic has 2 names, kind of like a main name to it and then a subname. So what are the 2? You'd say, well, Brian, this is a blank, but it's also a blank because of that down there. So this is called a what right here. Good luck right there, Blake, on the 201 exam. You got this, Blake. At 130, wish you luck. 100 points right there, Blake. Good luck on the exam. It's a time plot. Great job right there, Kai, right there. It's a time plot, and it's also a scatter plot. Those are the 2 things right there, a time plot and a scatter plot, because it's 2 quantitative variables where the time axis has time, or the x-axis has time on it. So it is a time plot, but it's also a scatter plot because scatter plots are 2 quantitative variables. So what is a decomp? Well, we can take this original series right here, and you might say, Brian, it looks to me like there is a somewhat what relation to this. Now, there's a somewhat what relation to this. This is what the decomp's going to do for us. There's a somewhat what relation to it. Like there's a somewhat QQ straight enough, no outliers. There's a somewhat maybe linear, right? So if we were to look at that part of the component of it, so we get like the 3 things decomposed. We've got like a trend cycle, and there's a somewhat linear relationship to it. Now then we would also have a sort of like seasonal pattern right here. And so the seasonal maybe goes like this. And then, so that's the seasonality right here. And last but not least, mostly trend cycle right there. And then last but not least, we have what we can't explain. And this goes to 320 knowledge. What do we call, and this will be big in chapter 7 for 201, what do we call what we can't explain, what we miss by, which we want to look like a white noise process. What do we call what we can't explain, which that looks to have a lot of correlation. 7 and 8, you bet. Jalen, we'll do that. We'll do that here next. Jalen, thank you so much. 100 points right there. Those will be next on the list. Residuals, or in the plots, it calls it the remainder. And the way this would look right here, and I call it the residuals, the remainders, they're what we can't explain, the actual minus the predicted from where the models would be off. I guess it does make sense more mathematically to call it the remainder because it's what we don't have. 201 exam, you cannot have any notes. No notes on the 201. You can have a blank sheet of paper. Make sure to review the announcement. No notes on the 201. Do not bring notes. Do not. No index card of notes. So what we'd see right here is this, and this is a perspective. All of these things here are the same size. So you have to pretend like this is like a dime. I've compared it to like a dime. So this is if like Brian were to look at a dime, it would look pretty small. So in other words, this right here, this component, how can a strong... Oh, Dylan, good question right here. We'll answer that next, Dylan. You got it. I can do that one really quick, Dylan, next. So that's our next question. So if you look at this right here, what is this thing telling us over here, right here, Colton? When you look at the trend component of this series, by seeing that this perspective thing is very small, that means the trend thing is very what? So you would say the trend is a what to this series, the trend being the green part of it right here. The trend is a what, since the perspective thing is very small. The perspective thing is the same thing in all the pictures. So it's the same thing, but it's very small in that picture. So that means the trend component, or the trend cycle, that's why it says TC right there, but mostly trends, some cycles the irregular, and the trend has to be very large because it's a comparison metric. But down here, and I like to draw like an ant or something, hopefully our remainder is very small. Here's our little ant looking at it. So the ant's looking at this dime over here, and the ant's like, whoa, that's a really big dime, where when I look at a dime on the ground, I'm like, oh, it's a little tiny dime. So hopefully, and this is what we would think right here, that means that this ant is living in the world of these blips right here. I'm living in the world of this. So this is very large right here, because think about me right here, but this is like a little small ant. You want your remainder to be very small, what is not explained by the trend and the seasonality, the trend cycle and the seasonality. So this is what we're trying to understand. And also, we would want one other thing when it comes to the seasonality, we'd want it to be relatively consistent. So that's a lot of what we're looking at right here. Let's write a little bit of the code, then we're going to answer Dylan's questions and Jalen's questions. So stay tuned, 201. Your questions are coming up here next. There is some crossover between these topics right here as we think through what is a decomposition of a time series right here, which is a quantitative relationship of data. Correlation stuff right there. And so let's look at what it wants us to do. It wants us to make the decomp of the, there's using the seats method. So it's got right here the volume. Now we're going to do something different. Here is what it has. Let me go grab. So revisit and create an X11 decomp using this right here, the X11 version, to create the decomp, interpret the patterns of the decomp. So I'm going to go over here and grab this. Let's do a little FPP3, our #1 book, in the chat. So the FPP3 book is a free book. You can learn some coding from it. Huge shout outs there to, what is his name? Rob Hindman. Huge shout outs to him. You'll see him here in a second as the book appears. And this book right here, great free book online, goes through all the coding. Is it FPP3? It's FPP. I should have put the 3 on it. So for the exam today, can we start? Yep. As long as you have a 90-minute window, you're good. If we wanted to instill the full time, yes. Make sure to start with the 90 minutes still available. So you'll need to start, and I'll probably be seeing announcements like, hey, make sure to start the exam because as the time gets in, you need to have the 90-minute window. And there it is right there, Rob Hindman. Right there, excellent stuff, and there's the gentleman himself. And so we're going to go ahead and search in the book right here and grab the X right there, hop over to here, and here we are. And literally right here we have the code. So here's the #1 thing, Colton. So this is where I'm going to kind of leave off here in a moment. But if you take a look right here, you can see the exact same sort of things we were just doing, right? So you can see the majority of this plot comes from the trend cycle. There's a positive trend going on right here. There is some decreasing to the variation in the seasonality, and there is some remainder here that might be a white noise pattern. This is a different series than the one we're using. You can actually just copy it like that. And going back over here to our R document, we can head right into here and drop in this code. Now, this is not the answer. Different series. So don't do this one. But we should be able to store the X11 decomp right there. It says it's not found. I might not have FPP3 loaded up. Lawberry FPP3. Oh, we need to get, so it's, we don't have the US employment. He might have created that. Ooh, where'd he create it? Here is, no, he's piping it. He's already using it. Going to where he created it. Exports. There's, he's saving the Australian beer. US, there it is. So here it is right here. He's creating it right here. And this is a seasonally adjusted model. So if you're looking for a seasonally adjusted, he goes through seasonal adjustment right here. I feel like there's so much for this contest exam. Remember, kind of tough to outline what to study. What do you think is the best resources to study? Definitely go through, and I would just do it in little chunks and try to remember each part. So I'm posting the exam sheet right here, and then we got a lot of questions. So let's put this in to create the data. There's the creation of the data. U.S. retail employment still not found because he's already, oh man. He is using so many data sets that, see, I always hate that. You know what we could do? Well, we're going to try to make the one he makes because I want to do that. U.S., here it is right here. Man, he just goes through and creates his own data sets. Okay, that's good. That's good. That's good. That's good. And there we go. We were missing the components of what we needed, but now we have the plot. So now we have the plot right here. And so Colton, this is the point you want to get to right here by getting the plot. Does this, Colton, how are you doing? Does this make sense? This is the plot we were talking about, visually speaking, and understanding how to interpret it. And the code is right there in the book on that section on how to create it. And then we need to know how to read this graphic right here to understand we're breaking down this into its trend cycle, its seasonality as shown up there. And you can see there's the components to start, and then we're going to decompose it into the remainders. I'm fine with getting the plot. Oh, and then were you wondering about the interpretations, I think you were saying? Thank you, Colton, so much. Rerun the decomp by using the seats, and I think we're using that method right here. There's the seats. Use the X11 method. Examine the seasonal portion and explain if this captures more or less of the variation than the X11 decomp. So how would you know, and I don't want to answer directly, but how would you know the amount of variation that this is capturing? How would you know, kind of relatively speaking, the amount of variation? How could you explain to someone if this is a bigger portion of the decomp, that if it takes more to look at that, not to directly answer the question, but how could you look at this prospectively and say, did that take more of the seasonality information? So like without putting a full answer in the chat, you see what I'm kind of pointing towards, Colton, right there, that oh, yes. So think about, I don't want to directly answer it, but if you're wondering like what, I think you're seeing it, right? That the seasonality component, when we look at how much information is taken and what component this is of the decomp, the perspective thing over there is going to then give us information of, was more information taken? Is this a larger or smaller component of the decomp? And so how does that look right there, Colton? Is that making sense to where to go with this? To be like, let me think of, because we don't want to just make these graphics. We understand what they mean. That's the number one thing we do in statistics. It's not about like, oh, here's a graphic. It's like, well, what does this tell us? What does that dime thing over there mean? What does this series mean right here? What does the change in seasonality mean? Is the seasonality consistent? So the big thing is, what does this all mean? And it's so crazy that this is real data. Colton, another 100 points. Great work right there. And I think there was a question, which we can do pretty quickly, which I really like. We're going to head over here and do a correlation question. Let's do it. Okay, there was a really good one. How can a strong relationship have a correlation equal to 0? So we're doing another question right here. We're going to do a lot of 201, I think. So if you got those 201 questions, drop them in the chat. We're about to do some practice tests too. Now, do remember, where are all the practice tests located? Okay. Where's the practice test located, 201? Let's head over here to the main screen. Where is that practice test located? If we don't do your question today, where can you always go for practice test? Let people put in the chat for practice. Where can you always go for practice tests? I can't speak. Where can you always go for the practice test? Can a correlation... I promise some true false. You're welcome, Colton. Great work. Come back with more questions if you got more. Colton, thank you so much. It looks like you're almost done with the assignment. That is awesome. We got a new one. Can a strong correlation, let's put this. A strong correlation can have a correlation of 0. I promise, true or false. Good to see you here, Alea, right here. If you have questions, let me know. A strong relationship can have a correlation 0. Let's first identify what strength is. Strength is what? Who can explain what strength is? Very true. Great job. 100 points, Leia, right there. Very true. Because first, what is strength? What is strength? How close? Kind of. And Grace, 100 points again, helping us out with that review 1. Drop your questions in the chat. It's tightness. And Alea, you are right there. It is tightness around the form. So we have some instances right here where we have a very strong linear relationship. But then we have instances of a very strong what relationship? This second plot is an example of a very strong, because it's very tight around the form being this thing right here. So the form, I wish I could just grab that, but the form is going to be the kind of way it is. So the strength is how tight it is around the form. That is a very strong nonlinear, right? And so if you draw around this, great answer is Leia right there. If you draw around it, you get kind of a 0 because correlation is 0 for this because correlation only measures what? Correlation is only a measure of what? Those are just guesses at it. Correlation is only a measure of what strength? So a strong relationship can have a correlation of 0 because correlation is only a measure of what strength? And let's put that right here. Correlation only measures linear strength. It only measures linear strength. So if there's a nonlinear relationship to it, that's why we have conditions QQ straight enough, no outliers. Great job right there, Dylan. Correlation only measures the linear strength of a relationship. So a strong relationship right here, that one's very strong, could have a correlation equal to 0 because there's no linear relationship to it. It doesn't indicate no relationship. It indicates no linear relationship to it. So that is very, very true. Good question right there. One of the trickier ones, but remember, correlation only measures linear strength, hence the conditions QQ, two quantitative variables, straight enough, no outliers. And you know what's really interesting? I do like to point this out all the time. What you're learning right here, does it look like the idea of linearity? You're welcome, Dylan. Yes or no? Does it look like the idea of linearity applies to like time series where we try to find the linear trend component to the series? Linearity applies to multiple classes where we talk about what is the linear component of this and can we then, decompose it. That's what we were just doing if you saw the time series thing where we're looking at the seasonality, which is just the fluctuations over quarters. And this is a time plot right here. So I love doing time series stuff. You can rewind the video and see the segment before where we decompose this and we got the cool graphics inside of R and we can just do the decomp right here to find out what is the linear trend or the linear, what's it called? Linear, oh my gosh, trend cycle component. Wow, which is the line. Anyways, time for the next question. Let's go back to the practice test over here. Here we go. We have open questions after this, so please drop your questions in the chat. I gotta listen to that one. Go over here. We need to go to the review page. Now, do remember, so let's do question 7, I think people were wondering about. So Stat Tool 1, practice test question 7. And Mubot's going to tell us about this in a second right here. There he goes. Let's go to the main screen. If you are looking to review, I would suggest focusing in on just take like these in chunks. You don't sit down and say, I'm going to learn all of Stat 1 in a day. You say, you know what I'm going to do? I'm going to review chapter 1. The speedrun videos are great right here because guess what? The speedrun video is 5 minutes. That doesn't mean you understand it, but it means you need to focus in for 5 minutes and say, let me take notes. Let me focus for 5 minutes. Let me get this. Because I made these videos right here to be smaller, to not sit down and review a whole chapter. It's meant to be like, well, it is a whole chapter technically, but it's meant to be more focused and quicker where you only have to pay attention for about 18 minutes rather than a whole lecture, and there's really no jokes, sorry. Here's the videos going over each one of the practice test questions. Put some more reviews on here. Don't know why I put those on that list, but they're on there. And then here's a video over each chapter, so you can go over comparing distributions and get kind of a review right here. 5 minutes? Man, that's quick. So anyways, great review options right here, and the practice test. So let's go to the practice test and take a look at it. Down here to the practice test, we're going to number 7. On number 7, we have the following. A high school football coach believes that the number of points scored in each game is correlated with how many hours his players spend practicing the week before. He records the hours practiced before 10 games and points his team scored in those games. I thought it says plots the points. Okay, so let's take a look at this. What is the first condition for correlation? What is the first condition? It first asks us to go through the conditions right here. So what is the first condition for correlation? Which we see by seeing a scatter plot. That would answer the question if the first condition is met. If you see a scatter plot, first condition is met. What is the first condition right here? And there's open questions after this. So say, hey, Brian, could you review a chapter 5? Could you review a chapter 4? Whatever you like. What is that first condition for correlation? And the condition goes something like this. QQ, Leo, 100 points. Good to see you here, Leo. We got right here QQ, which is 2 quantitative variables. Collier, great to see you right there too. 2 quantitative variables. So if we're practicing right here, we would say, and I would try writing these down to practice, I would say QQ, 2 quantitative variables. So both hours practiced and points scored are quantitative variables. So we're good on that. They're both quantitative. How do you pass QQ? Well, in long version of talking about it, it's 2 quantitative variables, QQ. If someone says, what do you mean by QQ? You're saying, well, I need to make a scatter plot. I need a quantitative X. I need a quantitative Y. That is required of me. So we meet that because we have it. So good stuff right there. Next, we have a condition called straight enough. Now, this is not the perfectly straight condition. It's the straight enough condition. Is the relationship decently linear? What do you say right here? Is this decently linear? Is there a decent linear relationship? Yes or no in the chat. Is it decently linear? We're not asking, is it perfectly linear? We're asking, does a line decently describe it? If I draw a line on that, will that look kind of like a line? Not that everything's on the line. We're just saying, can a line go through it? Hence, your usual failures on this one. Great job right there. Your usual failures are going to be things that look like this. That's a usual kind of like not following the line. So we're going to see another condition in a moment right here. I'm going to say, yes, this does mostly follow a line, but we're going to see the final condition has a bit of an error, which the final condition is what it says. So I'd say, yes, it mostly follows the line. The last condition being the no outliers condition. The last condition being the no outliers condition. SAD. I'm just on the home keys right there. So the last condition being the no outliers condition. Are there no outliers? Now, be careful. The no outliers condition is asked, are there no outliers? We're not asking outliers yes or no. So you can also ask this, do we meet the condition? That's probably a better way. Do we meet the condition? I've just had people answer this the wrong way when we ask, are there no outliers? Because it's a double negative. But do we meet this condition of no outliers, yes or no? It's like the better way to ask it that usually I don't see it. And Leia's great answer right there. Will questions be involving jump output, Andrew? Jump output is on the test. You won't have to like know how to like use jump, but you will know how to have to read the output. It won't be like, what would you click? But we see right here this outlier. So is the condition met? No. Condition not met. No. We have one extreme outlier where there was 40 hours practiced and there were 20 points scored. Missy wrote this question because it's football related. It's so funny. I'm not a big fan of football, but Missy Morris, big fan of football with all her sons. But I think she's a big fan of football in general, but all of her sons, big football players and stuff. So she wrote a bunch of football questions whenever we had exams, and you would think I'd write them maybe or something, but if you see a Rick and Morty question on the exam, I wrote that. Rick and Morty questions, Those are from Brian Stevens. Okay, so with this right here, we've answered the questions. We know that we do have an issue right here with the outliers. Not good. Suppose that point was removed. Suppose the correlation is calculated using all the data, but then we remove this point. How would the removal of that point impact the correlation? So let's look at a before and after. So the before is this. This is the before. And here is the after. What do you think? The number 14? We can. Good question right there, Leo. Definitely. We got one more after this, and we'll do question 14. So what do you think happened to it? Just look at it visually and remember how it works, that the strength, as we reviewed a moment ago, is the tightness around the form. So it's getting water by removing that point. By removing this point right here, the correlation is getting water. I can't really make it do that, but you kind of get the point of what I'm going for right there. The correlation is getting water from going from before to after. So this says after right here. If after the removal of that point and before the removal of that point, what is the correlation doing? It's getting water, which the tightness around the form is the strength. The form is linear. So we've already said it has a linear form with the straight enough, that it has a linear form. So it's getting water around the form, which is the answer to the question. So it's going to get water. So here's the before, and the removal of this point would then lead to something that looks like this, and that is tighter around the form. So since it's tighter around the form, that means that the correlation here is going to be stronger. So since it's stronger, it's going to go towards +1. So it's going to be stronger. It was already positive, but it's going to go towards +1 because it's going to be stronger. So good stuff right there. We got some question 8 next. Let's head back to the main screen. And we got question 14. Let me mark that. Thank you so much, everybody. We're trying to do as many questions as we can. So here we go. 2755. Stat 201. Practice test. Number 8. And then we have some 14 coming up here next. Okay, let's over to the main screen. Let's do it. Okay, so this one is using mosaic plot. Who knows what kind of variables make a mosaic plot? Good review right here. What kind of variables make a mosaic plot? Whenever you're making a mosaic plot, what kind of variables make a mosaic plot? So if you see mosaic plot, you'd say, oh, that's a what combination of variables. Can we do a graphing calculator on these? You can use graphing calculator. Good question, Vinny. You can use a graphing calculator. What kind of variables make a mosaic plot? So mosaic plots mean, BC, kind of. Categorical, Brittany, correct. And bivariate categorical. Oh, that's what Leo's saying. Leo, you're right. Bivariate categorical, yes. 2 categorical variables, bivariate categorical. Exactly, Leo. I'll give you 100 points. I didn't realize it. You're saying it correctly. You're right. Bivariate, which I was covering up right here. Bivariate categorical. That's in the bottom, like right here. So that's why I'm disappearing. Bivariate categorical. 1 categorical, 2 categorical, mosaic plot. So that's what we see on the screen here is a bivariate combination of categorical, X variables categorical, Y variables categorical. We're asking, what are these dolphins doing? Well, they're either traveling, socializing, or having food. And I don't know why the color looks a little bit weird there, but that's fine. So you notice in the evenings, they're feeding a lot. In the morning, they are traveling a lot. Or the afternoon, rather. Well, it's mainly in the evening they eat. They have dinner in the evening. Some of them skip their breakfast or lunch. Breakfast and lunch, that's one meals I'm eating usually. Lunch, I'm pretty bad about these days. I get up and eat breakfast. Lunch, sometimes. Based on the mosaic plot, approximately what % of these dolphins' mornings was spent traveling? Can anyone use a word right here? If we're looking at in the morning, they're traveling. So we're actually looking at a what distribution? Because it says in the morning. Does a word jump into your head? Because I want to look at given it's the morning. So what % of their mornings were spent traveling? So this is actually called a what distribution? What % of their mornings were spent traveling? This is a conditional distribution. Given it's the morning, what % of the time are they traveling? We gave a range of answers right here. What do you think is a good answer to this? Given it's the morning, what % of the time are they traveling? Who has just like a decent guess of this? We accepted a range of answers. I remember grading this exam. Graded in the main lobby of floor 2 in Stokely Management Center. I remember grading this one. I remember my TA saying, like, they answered this. And I was like, yeah, that's fine. So we'll be careful. Oh, wait, is it? Oh my gosh, I looked the wrong way. I looked the wrong way. I was looking at feeding. Oh my gosh. Wow, I got the wrong color right here. Leo, 100 points. Traveling is blue. That. So 50, and then make sure, so here's a good thing to do. It must be what to 50%? And Collier said it correctly right there. I don't know if I'd go up to 55 or so. I'd probably say like 52, 53, somewhere in that range, a little bit. 52, yeah, Grace, great answer right there. So a little bit more than 50% right there. I did the wrong color, but a little bit more than 50%. Probably, I think we set a range of like 51 to 55. I think that's what we gave as possible answers. And then maybe someone said 56 and we're like, sure, why not? But we were pretty generous on this. Like we had a little bit of a range to give. Now you wouldn't want to answer 50. That's where we'd probably count off points because it's more than 50. Like you can see right there where the mark is on 50. So we might take off points if you said 50. You might take off like half credit. So we just have a sheet usually on how we grade these things if we're grading a written test. But usually you'd get a multiple choice or something like this. Or the grading nowadays is standardized by it having a range of values. So we probably wouldn't accept 50 because it's more than 50. If someone said 50.1, I might be like, okay, sure, why not? They at least knew it's more than 50. Like that's what we're going for. So we're saying it's a little bit more than 50, 51, 52, 53, 54. Once you reach towards 55, 56, I'm like, maybe not. So that's the first one right there. Good stuff. Let's take a look at the next question. Make sure we've got a few more questions. We got one more after this, but ask your questions. Based on the mosaic plot, at what time of the day were the Icelandic dolphins observed the least? Okay. So now we are looking at the what distribution. Who knows the name of the distribution to talk about only looking at when they were observed? Who knows the name of that? If you want to talk about only looking at when they were observed, you'd be looking at the what distribution. Here's a hint. We only want to focus in on this margin to talk about when were they observed. So what would you do right here? And great job, Carter, right there. This is called the what distribution because we're going to look at that margin. We want to say when were they observed the least. So you can kind of look at the amount of area under here and answer the question that way. Since this is in the margin, it is called the marginal distribution. So when were they observed the least is the morning because this is a univariate display of when were they observed. So they were observed the least in the morning. So this is the marginal distribution of when they were observed during a certain period, and they were observed the least in the morning. Next question right here being, is there a relationship between activity and period? So what do we need to look at to see if there is a relationship? To see if there is a relationship, we'd want to see differences in the what distributions, which we do see. If we want to say there is a relationship, we'd want to see differences in the what distributions, which we see some mostly there. But would you want to see differences in the what? Like, given it's the afternoon, they're doing different things than given it's the evening. So we'd see differences in the what distribution. I'm putting a letter right there because those are different whats. So this would indicate that there is a relationship, and those are called the what. If I say given it's the morning, given it's the afternoon, and I look at that sort of like given this is true and go within that, those are called what distributions right there. So those are called the what distributions. Like given it's the evening, they're feeding a little bit more than they usually would compared to if it's the afternoon. And that shows there's a relationship. Like, oh, it's the evening, the dolphins probably might be feeding. Oh, it's the afternoon, they're likely to be traveling at that point, more likely than they would be in the evening when they're doing a lot of socializing and feeding. They do travel in the evening, but they're more likely to be feeding in the evening. These right here, these distributions talking about within one value of the x, looking at the other value of the y variable, are called the what. What does the C stand for right here? Who knows? 100 points in the chat. We'll see. And then we got the last, I think, question on this. So these are called the what. Like given it is the evening, the probability the dolphins are feeding is close to 45%. Not correlation. Good guess right there, Carter. Not correlation. The conditional. And thank you, Leah, right there saying no clue. Don't worry, that's a good answer. These are called, and this is review, conditional distributions. The conditional are within the plot, and the marginal are on the outside of the plot because they're in the margins. So these are the marginal. Don't worry, I don't know is a great answer. Or just say, I no clue, I forgot. Don't worry, it's been a while, Brian. These are the conditional distributions within here. So we got a little color coding to help out. These are conditional, like given it's the evening, given it's the afternoon. And so, Carter, good thing to remember. If we ever say correlation, what is a requirement? If we ever say the word correlation, we would need to make sure what? Go back again, just to remember. If we ever say correlation, we need to make sure what? So I'm going to pause here because this is a big thing to remember. Whenever we say correlation, we need to make sure what? So this is why it wouldn't apply to that idea at all. But Carter, don't worry, another 100 points. Whenever we say correlation, it's like, oh, we need to have this. So whenever we say correlation, we need to make sure we first satisfy what? Which is why it wouldn't apply to the other idea at all. So what do we need to make sure? If we ever say correlation, what do we need to know? If we ever say correlation, last sip of coffee, QQ. And that's why it wouldn't apply to this idea right here because QQ, great answer. 2 quantitative variables because this is 2 categorical variables. So there's no correlation right here. The idea of correlation does not exist. The mosaic plot has categorical. Great answers, Leo and Carter right there. So this would be the idea of not correlation, but the idea of association, which is or relationship. Relationship and association are synonymous words, but the idea of a relationship is not always a correlation. A correlation is a special kind of relationship that is only between 2 quantitative variables. So correlations are special kinds of relationships that are only between 2 quantitative variables. Make reference to the plot, and we did that right there. We talked about the differences between the afternoon and the mornings, and that's got it. So we mentioned that in our answer. So let's go ahead and do question 14. We've got open questions after this, so drop your questions in the chat. We're doing question 14, but whatever you want, we can do. If you're reviewing right now, it is your time to ask any question you want. Ask those questions. We got some pivot stuff right here. We got a lot of pivot information. Oof, pretty complicated pivot chart. Pretty cool shadings right there on the pivot. Below is a pivot table of the rate paid by a passenger by the region. Okay, so this is the rate. This is how much they were paying. I'm going to zoom in here. I'm going to disappear. This is how much they were paying. $2,300 and something dollars, $2,300. Okay. And then we got here $2,280. Looks like these are mostly lower. These are mostly higher. And then if they are part of the loyalty program. So these people are in the loyalty program. These people are not. And the first thing I notice about this is people who are in the loyalty program are for the most part paying lower rates than the people who are not. There are some differences though between, I think this is country, is it? Region rather. So quantitative observations can go in the values. Correct. These are quantitative observations in the values. This is how much did you pay? And I believe we're looking at the average. So as it says right here, average. So these are all people who are not in the loyalty program, who are in Europe, North America, South America, and United States. So North America, non-US. And then the categorical can go in either the columns or rows. Well, but the thing is you can use categorical in the values. You can do that. No, you're right, Leo, right there. We generally use quantitative in the values, but you're not. So here's the thing. What can pivot tables use? They can use quantitative Y's or X's. They can use categorical Y's or X's. Pivot tables can do combinations of anything, whether it be in the rows or the columns. A lot of times we do use a quantitative Y because we want to look at the average, but you're not required to use a quantitative Y. You can do quantitative values, but you can do categorical values to look like the counts of something. So it's very possible to use a categorical variable. So yeah, it's asking what is going where. And so here's the thing. So rather than it being confusing which one is in the rows and the columns, they're helping you out right here by saying loyalty program is in the rows. Yep, like the last visualization. This is a really good way to ask this. I don't know who wrote this question, but this was really excellent because we're splitting it apart right here. We need to take a screenshot of this. I wish I had written a question this good. It's just very well thought out. It's a very good, where would you put this? So the most important thing to us, whenever we make a pivot chart or pivot table, is we're thinking about what are we displaying? And what are we displaying goes in the what's, Leo. What are we displaying always goes in the what's. So what we are displaying goes in the what's. So what we are displaying goes in the what's. Whatever we are displaying goes in the what's. Make sure to click. There's a thing to get to Proctorio support, Cassandra. There's a thing that when you go back through to reconnect, it'll have buttons. There'll be a thing up here on your browser window that says like contact Proctorio support. So you want to click the thing. It looks like a shield, Cassandra, right there. It'll be a little shield button, and you want to click it, and it'll connect you to Proctorio support. Make sure it should say like reconnect. You need to connect. It'll have a person you need to talk to, or like they'll go up in a little chat window on the bottom side. And so make sure to click that little shield window in your browser for Proctorio when you're going through, and it should do it. Make sure to click through it'll have instructions saying, you know, here's what to click, here's the thing, and it'll show the thing up there. Might need to look at that between things right here. Cassandra, after this example, I'll take a look at that. So give me a second, Cassandra. You got it. Thank you for messaging me right now. We'll take a look at that here. So with this right here, and Cassandra, we might need to hop on something real quick right here. Might need to jump on the Discord or something, or the Zoom, whichever works for you. So with this right here, the first thing we always look at, Leo, is we always figure out a what to display. And we'll finish this question up here, and then we're going to look at that real quick. We always figure out a what to display, Leo, not a columns to display. The number one important thing to do when we look at pivot charts and pivot tables is to look at a what to display. The most important thing, Cassandra, can you send me a screenshot of what you're seeing right now via email, and I'll take a look at that next right here. The values. The value is what we're going to display, and that's our number one thing to think about. The number one thing to think about is the value we are going to display. And the value we are displaying is the what. The value we are displaying is the what name. What is the name of the value we are displaying? We are currently displaying the what right here. Now, I know we're displaying a like a quantitative variable, an average, but the variable that we are displaying is what right now? The variable we are displaying is what? The variable we are displaying right now is what? Like the variable we're looking at is what variable? We're looking at the average of it. We're looking at rate, right? And so we are looking at average rate. And so that would be the setting for the value field. Good answers there, Leo. That would be the setting for the value field. And Cassandra, send me some pictures of what you're seeing, and I'll help you through. It would be the rate right here. It does say it's been filtered out by diner section. So diner seating. So that literally says right here, we've filtered on that. So that would be the filter. And then it's already giving us that loyalty program is right here. And region would need to be the other one. Like we're splitting it apart by these. One is in the rows, one is in the column. And that's kind of how you split your data apart, because one is going to be over here. Well, there's the region. And so we would have region right here. And then we would split it apart by loyalty program, yes, no. And then the values we are looking at are going to be the values in the table. And those are the values being displayed to us right here. So I really like the question. Briefly explain one inference about the pivot chart. Be sure you have numeric support. So the number one thing and number one problem whenever I see visualization is quote numbers. So I could say it is clear to me that people who are in the loyalty program are paying less, because the highest amount paid in the loyalty program were people in Europe who were paying 2,280.25 on average, where the lowest amount paid in the non-loyalty program was Europe, which was 2,316.88. The fact that the people in the loyalty program who are paying the most are still paying less than the people who are not in the loyalty program shows me that there seem to be some apparent differences between what people pay on average who are in the loyalty program and what people pay on average who are not in the loyalty program. So once again, I kind of went and talked about the key difference I see right here, where we could compare the highest group right here to the lowest group over here. So the highest loyalty program versus the lowest non-loyalty program, and then kind of talk about those differences. So for pivot charts, there are two categories. There can be. Pivot charts allow you to do anything. We could just do one variable. So pivot charts allow you to analyze any sort of combination of categorical, quantitative. Terracita, great question right there. Pivot charts and pivot tables allow you to analyze any sort of categorical, quantitative combinations of variables. You don't have to do it with two categoricals or one quantitative. Any combination you want. And we've got time for more questions. Put them in the chat. Okay, I'm going to go over here to the main screen. I'll be back in 1 second. Let me put up a be right back thing. Here we go. Okay, we're back and we're taking questions. And Cassandra, I sent you an email right there, and I've extended the time so you can get back on. And I think so I'm kind of diagnosing right here too. So I think go back to like the main page of it, like the main exam page, and like try doing that. Like try going through the main, because I think like go away from that screen. It might be easier. You might be seeing my email now, but go back to the main, like where it says like exam 1, and try going through that, then like where it says like exam 1, click through that, and show what it shows there. If we need, I could probably hop on a Zoom call or something, but we'll see if that works. But it should do that. It should and you have a second screen. So it's saying cannot connect to server. And it should, we might need to hop on a Zoom call. Let me look over at the chat. Let me message you here. Can you join a Zoom call? Might need to do that. Let's see what chat is saying. If you have questions, put them in the chat. If you have questions about the review, put them in the chat. We're just hanging out right now. Let's see. See if I have any urgent messages over here. Seeing what the... Here we go. Let's take a look. Okay, good. Everything's going good there. Nothing's on fire yet. If you have any questions, drop them in the chat right now. Who has questions? Let me put up the taking questions sign. Let's go right here. Taking questions. What's the Discord thing? Oh, that's the Discord video. If you have questions, put them in the chat. Taking questions. If you have questions, put them in the chat. Oh, the cool, Leo. Awesome. Maybe they've logged back in. That might have done it. Awesome. Seeing if there's any... Interesting. Good deal. Awesome. Oh, that's awesome. I got good news. Someone feels like they do well on the exam. It's awesome. Making sure... Go. Let's see if there's any questions. So this is word weird, but just wondering. Oh, yeah, here we go. What are the main things we need to know for the pivots for a 201 exam? What are the main things we know? Kind of getting scared. No, don't worry. This really, but just wanting to know about pivots. Yeah. Okay. Let's think about pivots right here, and let's go talk about the pivots. You boss just talking away right there. Let's go talk about pivots. So let's talk about the pivots. Stop. Stat tool 1. Reviewing pivots. Okay. Here we go. Reviewing pivots. Let's do it. So when it comes to reviewing pivots, what do we need to know? What do we need to know about pivot charts and pivot tables? Well, basically, and I'll say this, if you did the assignment. I usually feel pretty safe that people can understand how to read pivot charts and pivot tables. The number one thing to do is to know how to make them and understand what you can do. When you're making a pivot chart and pivot table, everything needs to be formatted the exact same way, as in all these yeses and nos. They're on Excel. That's important to know right there. Starter out right there. 100 points right there. They're on Excel. And everything needs to be formatted the same way for every single observation we have. We're just going to start making one right now and start talking about it a little bit here. We'll go to pivot table. We'll insert it. And now we have a pivot table started. Now, one thing to know is that you don't have to have one quantitative, one categorical variable. I could simply just drop in here Greek life into the values, and that's kind of the most important thing to look at. Greek life in the values right here actually just tells me how many people answered my survey. So this is the count of observations for the people who answered the Greek life question. This really isn't that interesting, and it just looks like this. So this would be 628 people gave a response to Greek life. Greek life is a categorical variable, so we don't really have as many options on it when we go to the value field setting, or we shouldn't. Even if we do average, it's going to get mad probably, and it says you can't do that because this is categorical. So that's why we can't do the average for Greek life, because it's a categorical question. Now, one thing that often is confusing is you have to put Greek life in a second spot to actually break it apart by are people in Greek life. It's pure cosmetics which way you want to put it. I frankly think it might look better to put it like this. And then what does this tell you right here? So what is this communicating to you? Now, we're not doing a quantitative variable, but what does this communicate to you right here? What do you know for most of UT? Most of UT is what? By looking at this graphic, most of UT is what? So we're seeing that a pivot table can display for us categorical or quantitative variables. We don't have to always display a quantitative. We do need to put something in the value fields. So the value field needs to have something in it. If you remove this, we're not going to get anything at all. You always have to put something in the value field because those are the values you're displaying. Out of the most students are in Greek life. Exactly. Great answers there, Leo. But right now, our graphic is not really conveying information pretty well. What should we do to this graphic? And that's a good question too. What should we do to this graphic right here? This graphic is not communicating information pretty well to us. This graphic is not communicating well to us. This graphic does not communicate the ideas pretty well to us. Helping out right here. Titles, all that great stuff right there. Titles, access titles, all those great things right there. And so right now, this does not display the information we're looking for properly yet. We need to add into this a lot more things. So we can go here to, if you're on a Mac, we need to go over here to the add chart elements and go to access titles. And so we'd want right here things like, oh, you know what I'm going to do? I'm going to go the easy way. Watch this. Quick layout, boom, right there. That's the easiest way to get everything you want. Maybe, I don't know. All depends. Well, then you can change the color of this one. So let me go. I don't like that it doesn't have color right here. So you can change the fill and all these other things. So we could go and change the fill of it to that if we want. But I'm going to go like this. Sure, why not? And now we have our information displayed. But we could actually see gender compared to Greek life. And it looks to me, well, we had more females take the survey. But once again, this is looking at the counts of individuals. Counts of individuals. So the title of this, which we don't have a title right now either, we want to add a primary horizontal. So these are the things we would want to add to it. Primary horizontal would be gender. And then we'd go right here and we'd add a title. And we want to go to chart title and go to name. Oh, why can't we get a chart title on this? Above chart. There we go. Count of individuals in Greek life by gender and by gender. That's it. And we can put prepared by, but that's not needed if we're just going to present this at a meeting. But this right here is a pivot chart that I think could be displayed to people to convey information. We want to think about how things are rounded. I did say it never hurts to add one more decimal, so we could do that. This one, since it's whole numbers right here, technically it's not needed. But if you go by Brian's statement of it never hurts to add one more decimal, you could add one more decimal right here just to show that you calculated to that. I do not think it's the end of the world to add one more decimal. These are whole numbers, so it's not required. But Brian's statement of it never hurts to add one more decimal does apply right here to say this is what we measured it to. A lot of times we do that in science. And so this right here is going to communicate the idea of we see generally about the same amount. It looks actually that females might be a little more involved in Greek life. If you look at the females right here, we see that out of the females, there are 224 plus 119. Oh, what did I do? 224 plus 119. That's the percent. Oh my gosh. There we go. 65% of females are in Greek life as opposed to the males who are in Greek life. No, that's not right. 65% are not in Greek life as opposed to the males. What am I doing? 74%. So there's a little bit more males. That's 70, like not in Greek life. 74% of males are not in Greek life as opposed to 65% of females. So yeah, something going on right here a little bit, a little more higher probability. My last quick question here, and then I'm going to go help someone real quick. My last question about this is what would maybe be a better way to display this? What would be a better way to look at? Is there some sort of association between males and females being in Greek life? So we could use Excel, but what is a better way to maybe display this to talk about is there an association between males and females and them being in Greek life? Is there some sort of association right here between males and females and whether or not they're in Greek life? What would be a better way to talk about this if we were to look at males and females and to ask, are they in Greek life? A better association or a better way to display this if we have access to things like jump might be to do what? Might be to make a mosaic plot. A mosaic plot is going to do the same thing we were just doing. And remember how I said with males, it was 74.04 right there? That is the percent I just calculated for males, given someone is male. So there's the percent right there for you. And then it was like 65% for females. There it is, reappear. 65.31. So we see that a little bit more females are in Greek life than the males. So once again, this is kind of doing the same thing we just did, but it's stacking the bars at least, or making a mosaic plot out of it. And we can see that females are more likely to be involved in Greek life than males. I'm going to go check. We got the Be Right Back screen up. Be right back here in a moment, making sure everything's going all right. Hey, we're back, everybody. How are we doing? Leo, Teresita, Kaya, good to see you here. Zachary, we got time for a few more questions. Let me send out announcements regarding 475. Please discuss patterns. I know them in theory, but when we were talking about them in class yesterday, I seem to have different thoughts. Ooh, Kelton, good question there, Kelton. I'm going to send out a quick announcement to all 201s that I have saying afternoon review session coming up. So give me a second right here, and then we will do that question next. Thank you so much, Kelton. Content. Test 1 review. All the tests tonight. Announcements. Here we go. Reviewing in 40 minutes. Reviewing in 40 minutes. See you soon. Join in and practice for the test. Click here. Okay. Viewing for the test in 40 minutes. Click here. Okay, there we go. Boom. Okay. Got everything sent out. Good to go. Also, I'm reading the books. Explanations how they reach the conclusions do not seem immediate. Oh, which part are you reading there, Kelton? Which part are you reading from the book? Let me know. Let's go look at some patterns right here. Here we go. Time series patterns. Let's do this. Oh, here to the main screen. Okay, so we're on here on 105.35. So BAS 475. Time series patterns. Okay. So when we talk about these time series patterns, what are the 3 patterns, Kelton? So the first thing we need to know here is, what are the 3 patterns? Like, that's number one thing to know is, what are the 3 patterns? We have this, we have this, we have this, or I guess if you say it that way. I've got right here kind of the 3 patterns, but not totally. So the 2.3, the 2.4, I'll go look at those in a moment here. This is kind of, not totally. We see right here the original series of employed. This is the amount employed. And then we have 2 of the 3. Great job, Kelton, right there. We have here the trend. And so I really hate that they do this, but the trend right here also has cycle in it. So you might see a little cycle here, a little cycle here, a little cycle here. Cycle does not have a what period. Like where seasonality, another thing you mentioned, has a very fixed period. The cycle portion, which is used in the trend right here, this is the trend cycle. It doesn't say trend cycle, but trust me, it is. The trend cycles do not have a what period, where seasonality, this is quarterly data, I think, or no, it's monthly, I think. So this being monthly data goes through a 12 monthly period. Want to hop on? Yeah, of course. Yeah, Brandon, I just sent the announcement right there, so you should see it. We are reviewing in 40 minutes. Good question, Brandon, right there. So when you look at the cycle, which is a component of the season, right, or the trend right there, excuse me, cycle doesn't have a predictable period and it ranges over 2 years. It can. In this instance, it might. I dislike how they give a minimum length before something can classified as cycle. All these things are just words to kind of understand what we're seeing. Cycle is just like things might go through different cycles. Think about how the world might have warming and cooling periods where we might go through like an ice age or a heating period. Now, it does not mean that every 1,000 years we go through this. It might be over like 800 years, then 1,000 years, then 1,100. You might have more predictability in cycles, but when it comes to seasonality, the number one thing to know about seasonality, which means it's seasonal is over a very, very what? Use the keyword, all seasonal data has a what period. The seasonal data, the seasonal component, which there can be 2 seasonal components. That's interesting to talk about. But the seasonal component is what? It is a very, very what period. Keyword that you have to know for the seasonality of data is that seasonal data is always over this period. Like whenever you think a seasonal pattern, it's got to be like weekly, very fixed. 100 points right there. Seasonal data is very fixed to like monthly, weekly, daily, hourly, quarterly. So you have to have that fixed period of time for seasonality. And so the seasonality is a fixed period of time denoted by differences in quarterly data, weekly data, monthly data. I think this is monthly right here, where the trend is what we think of often as linear. It could be slight non-linear, like what is it trending towards right now? There's been kind of a slightly increasing linear pattern right here, some linear relationship to it. Very fixed, exactly. And then when you think about cycle is going to be kind of think of it as like pulls to the trend. So in this instance, that's the best way to think about like the cycle of something. Oh my gosh, that did not feel good. The cycle of something, I really should just, you know what I just might do right now? I just might go buy some AirPods right now. It comes in the mail and I just tell my fiance, I'm like, oh, I just bought some pair of AirPods because I was like, I keep ripping my headphones out of my ears. I do it so often. So the whatchamacallit, the candy bar, the trend also has the component of the cycle in it. The trend also has the component of the cycle in it. So if you're thinking about trend, it might be something that's mostly linear, where cycle is going to be some pulls to it. It's going to pull it down. It's going to pull it up a little bit. And we see right there. Now the remainder in this, or the irregular, I hate how it has about 1 billion names. I wear those same classic headphones. Exactly. I put my dog harnesses. He freaks out when the cord. Oh, exactly. Yeah, I know, right? It's the AirPods would be pretty nice right there. And so the irregular right here is things that are not following this pattern. It's just different, graphics are gonna call it. I got some AirPods and they're kind of awesome. Yeah, I know, right? 100 points right there for some AirPods. My fiance has them. I bought them for her, and she was like, I don't know if I'll use these. Then she used them, and she was like, okay, these are awesome. Yeah. So first instance of her using them was she was like, these are great. I might be able to fix this graphic. I'm wondering. Well, the auto plot's doing it. The components is the issue. That's what the issue is. So let me go look at this output, because then we're storing it into X11 decomp. Okay, so this is easy to fix. I don't like that it's called irregular. That's ridiculous. Irregular is a ridiculous name for it. So this is the 1, 2, 3, 4, 5, 6th column name, it looks like. So since I don't like that column name is called irregular, there it is right there, irregular. I'm going to go to the 6th column name. I'm going to call it remainder because I prefer to call it that. And that is not what I want. What? That's not the decomp. Where's the decomp? Oh, does it get mad if I don't? No way. It's got to have that? You got to be kidding me. It might not like when I rename it to remainder. It doesn't like it. That's interesting. I didn't know that. When it plots the decomp, it looks to... See, now it plots the decomp, but when I rename the column name to remainder, it says no. Still doesn't like it. Maybe it's changing the... Oh, I know. I think I know what it's doing. I think it's changing it from a Tizbol or something. I think this is a Tizbol or something. Let me look at the class of the decomp. X11 decomp. Currently has decomp all this right here. Now, when I change it, I think that changes its class, and it loses the decomp Tizbol. I didn't even know that's a decomp time series right there. Please reiterate the irregular. That's just the remainder. That is what is unexplained. That is like residuals. It's what is not composed of the trend, the seasonal. This is the last component right here, which we do not encompass with these. So we were doing a graphic of this earlier. I think it's about 34, 35. No, it's a little further back. So what we're trying to do when we think about a decomp, I just want you to think about this conceptually here, Kelton. We're taking, just use the words. We're taking this data right here up top, and we are whatting it. Like, just use the word of what we're doing, what it's called. We're going to take this series of data, which we wouldn't see all this yet. We would take this series of data and we're going to what it. So we're going to take this series of data and we're going to what it, which is the chapter we're doing right now. We're going to take this series of data, and we're going to do what to it. So we just have data right now. Here's what we're starting with. We get data. Someone says, here's your data. You say, oh, I'm going to do what to this data? What are we going to do to it? The name of the chapter. So what are we going to do to it? We're going to what this data? So someone just says, here's data. Here's a time plot. And we say, okay, it's on quarterly data. We're predicting price. Basically, and that's the thing. We're going to decompose it. So it's like if you take something and decompose it, you're going to break it apart into parts, or you're going to decompose it. Like we should just call this the ripping apart thing. We're going to rip this apart. And someone says, well, I'm going to rip out the what of it. This person says, I see this and I'm going to rip that out of it. Like we're going to take that out of this. We're going to rip out that. What are we going to rip out of it? So we're going to rip this out of it. What are we going to rip out of this? That person's ripping out the what of this. That person has ripped out the what of it. They have ripped out the what. They've removed the trend of it. Next person comes in and says, I'm removing out the what of it next. Next person says, I'm removing out the what of it next. They say, oh, I'm going to go in and I'm going to take this out of it. They say, I'm going to remove out the what of it. Someone says, I'm going to remove out the trend of it. Here's the trend. That is the trend of the data. Next person says, I'm ripping out the what of it next. I'm just going to take this out of the data. I'm going to be like, ooh, take that out of it. I'm ripping out the what next. Next person is ripping out the what. So let me just remove that. The seasonal, predictable over a fixed period of time. And trend technically, trend has the cycle pattern too. But here's the thing. The whole point of doing a decomp is when we take these right here, we could take these components that you see right there. The trend, the season, and the remainder. And we want to put it back into the original series of the data points, the Y values, over a time. And there's a few ways we could do this. 2 ways we covered, because turns out there's 4, because the X13 decomp has like a log this and a pseudo this. But you could take these vectors, and you could what those vectors right here. You could what those vectors, and we could show this. You could what those vectors to get your original series, because that's just like just think of this. It's like it looks complicated, but it's just A, B, C equals D. Now that's not how we write mathematics, but what could you do with them to do this right here? You could solve for D where A, B, C equal D if they are what? And these are the 2 types of decomps we have. So the 2 types of decomp we have are what? No, that's different. That's transformations. We could talk about that next year. That would be transformations. Those are transformations. So we could do what with these components? You have these components, and how are you going to put these components back together right here? Oh, yeah. So how could you put those components back together? So you have these components right here. I give you a bunch of parts, and I say, put these back together. What are the 2 ways we can put these back together? So it depends on how we break it down. But what are the 2 ways we could put this back together? You could put them back together with addition. This is called an additive decomp. Or you could put them back together by whatting the values to say, well, the trend plus the season plus the remainder, or multiplication, right? Or you could do multiplication. Now, this leads to some interesting ideas right here, because you could actually remove out the seasonal component by doing this, and you would still have mathematically the same thing, but you would get the following right here, and this is going to be the seasonally adjusted for a multiplicative model. A multiplication model, or we call multiplicative decomp, is going to be the seasonally adjusted where you divide out the seasonal component, and you would no longer see the seasonal component in the series because you've removed it out. You divided both sides and removed out or adjusted for, so seasonally adjusted. That would remove out the seasonal component. So you're going here and you're saying, I don't want to see the seasonal component. You would be just looking at the trend and the remainder. And really great stuff in the FPP3 book on this, on how to look at just the seasonally adjusted, which is in our assignment. And when you think about, so if you adjust it by trend, would that be dividing by trend? You could remove out the trend. I don't see a lot of people do that. Then you would just have the what. If you removed out the trend, you would have the what. So if you removed out the trend, you would have the what. There it is right there. You would, if you removed out the trend, you would have the seasonal and the remainder. I don't see a lot of people do that. But look here, you see the trend for this data right here, and you also see the remainder. Since it's removing the trend is only seasonality, well, then it would include the remainder still. So if you remove out the trend cycle, you would see seasonality remainder. Does that make sense? So if you removed out the trend, so if we did, which is possible, we can mathematically do it if we want. I don't think I've seen a lot of people do that. But if you were to go here and say, let's remove out the trend. So if you said, let's like take out the trend of this. So we don't want to look at that. You would have here trend divided by trend, which when you reduce this, it's going to look like, it's going to still look like that. I need to focus on the remainder then too. Yeah, exactly. The remainder is still a component. The remainder is what's not explained by the trend cycle or in the seasonal. So the remainder is what we don't have. So at this point, your series would look something like the composite would look something like this. So it's going to have the seasonality, but it's going to have the remainder. But what do you not see in this data that I'm drawing down here? You don't see any what in this data that I'm drawing. So you see the seasonality, you see this. So you can see the seasonality through it, you can see the remainder, but you don't see any what in this data. Hint, you don't see any of this sort of thing right here. You don't see any what in the data. If I were to do this mathematically, you do not see any what right here. So this would be a trend adjusted data set, which I don't think I've ever seen this, but you could do it. You can do anything you want. You don't see any what in this data set. So you do see the seasonal pattern, but then you see the remainder, which is the unexplained or the component not comprised of the other ones. And all this right here is in these vectors. I think we did a additive decomp, so I keep destroying my decomp right here. But we should be able to theoretically. Do you see how we have the seasonal, the trend, and the irregular right here? Watch this. These are vectors. That's the month. That's employed. That's the trend. So take a look at this vector right here when I create it. What we should get, because I think this was an additive decomp, here's these values. Let's just call these original. If we look at the head of the original values, I'm hoping, and I think it should be, take a look at this. How did I get? No, that's the value. Ooh, are they a little bit different? Was it not an additive decomp? Oh, that's the trend. A little bit different. Seasonally adjusted. There's seasonally adjusted data. Was it not? Oh, it's multiplicative model. Do you see it? It's a multiplicative model. It's right here. They're multiplicative. So I made a mistake. This is not an additive model. That's why my data did not turn out the right way. It's a multiplicative model to make the original data. And then if we look at this right here, here's the first observation, and you can actually get a little more decimal place accuracy. So there's 12 right there. And so do you see how I literally took to put back together these components? What did I do to them? Does that make sense, Kelton, right here to see this example with this? To put these components back together into the original series, I had to do what to those components? I took the trend, I took the season, I took the irregular, and I whatted them to put them back together. You know what's really interesting? You can see a lot of this comes from the trend. A lot of the information we have right here is the trend. Like when you think about what is making this value what it is, it's really the trend. The other numbers are very small, but the trend is what is really controlling a lot of this data right here. Exactly. So this was a multiplicative decomp, as it says right here when it's saying that's the form of it to know. Multiplicative decomp over a fixed seasonality of 1 month. And then we see here the model is X11 decomp. It's the same thing. This is the month, which is the index. Important to know what indexes are. Here is the original data, which is the measure by which we're taking the data. We have here the 3 components, and we do get a seasonally adjusted model, which is going to remove out the seasonal component. So we should be able to make the seasonal adjusted model. Seasonal adjusted is just going to remove out season, which is this. So we should divide that out. And what we should see here, if we go, well, I don't want to call it original anymore. Okay, I'll just do that 10 times. S adjusted. And if we have S adjusted and do head of S adjusted, And those values right there are the seasonally adjusted. By doing the seasonally adjusted, I just did not include the what. So Kelton, to review, because the code helps, but to do the seasonally adjusted, I just did not include the what in my computations right here. To make the seasonally adjusted model, so it's been adjusted for season, think about what the fifth column was, which is not included. When I did the mathematics to put it back together to make the seasonally adjusted model, I just did not include the what component, which means I divided it out. I did to do the seasonally adjusted model, you remove the seasonal portion. Exactly. And so now we have the seasonal adjusted vector. But here's the really great news. We need to understand what this is doing. Like, we need to know, what is this doing? What is a seasonally adjusted model? But two, we don't have to solve for this. If you want to plot the seasonally adjusted data, guess what? Auto plot, or let's take our X11D comp. The easiest way to plot the seasonally adjusted should be here to go to auto plot. And then we should just go here to seasonal adjusted. And whoops, there it is right here. Well, really? Oh, there's the seasonally adjusted and it's decomping it. Ooh, I don't like that. Let me go here to X11 decomp. Let me take the seasonal adjusted. Let's say S adjust. And there's S adjust. Auto plot. S adjust. Oh, it doesn't like it because it's not a Tizble or something. Oh, really? Numeric. As dot Tizble. Oof. Let me do this. Let me take my S adjust data. No, we're going to S adjust. And we're going to take X11 decomp. And we're going to take column names, month, and we're going to take column names, seasonally adjusted. This is a horrible way to code. Let me code in the actual spot. You don't want to code down here. That's throwaway code. Okay, let me look at this. Always look at what you create. Oh, what did I create it? Oh, because I had an extra P. There we go. Oh, it's mad? What is it mad about? There's that. Oh my gosh. There we go. There we go. All this to get an auto plot. There we go. There's what we're looking for. And of course, we got to make it a cool color. I think you have to do color on this. Nope, you can do that. And we got to give it a title. So that's the auto plot. So GG title. And seasonally adjusted model. There's the title. Now we got to center our title. So easy center title. There we go. That's got it. And what we could do is we could even compare our original data. So watch this, Kelton, right here. Everyone knows I love making graphics. So we could go right here and go graphic 2. And what we could do is take our original data. The original data is going to be the employed. What was it called? Employed. It's going to be the original data. And there's that. So that's graphic 1. Here's graphic 2. And we'll go orange on this one. And that's not what I want yet. What did I do? It's mad about something. Problem with mutate. Ooh. S adjust, seasonal adjust, employed. And what's it mad about? What is it mad about? No, it's mad about something. There's the data. Okay. Hey Brian, on activity 5 for BS320, are the SSE values for the naive versus regression supposed to be the same? My output, if you do the model, make sure to do it with the tilde 1, John. So do the tilde 1. The SSE for the naive will not be the same as a X variable model. So in the chat right here, John, let me show you. You need to do Y tilde 1, save this into an LM, and then run the ANOVA on it. And this needs to be your model, though. Does that make sense, John? So your model needs to be the naive model to find the SSE of the naive. Good question. A lot of people have asked about that. I've got a few emails on it. But make sure to do the y tilde 1, so price tilde 1. I believe you're predicting price tilde 1, and then store that into the object M, and then run an ANOVA on it, and the sums of squared on the residuals of those ANOVAs. We're talking about some residuals here too. But John, 100 points. Thank you for asking. Anytime, just ask those questions. Is the one for the naive? It's for the naive. Simple models have 1x. The 1, which is kind of confusing, just means no x's. I know it's like, well, 1, well, you think simple, like 1x variable, but it'll have no x's when you do that right there. So y tilde 1 in the LM format. So M save into LM, y tilde 1, data equals data frame. This is the naive model. If you put an x right here, this is what we call a simple model with 1x. Does that make sense right there? Oh, Leo, we got this. I know it builds. It's like you learn. You're like, oh, I love seeing where people get to in these classes, because people start teaching me things. People are like, hey, Brian, you should do this. You should check out this. And I'm like, oh, whoa, that's cool. What is it mad about? Why is it mad at me? It's mad about something. You know what we're gonna do? We're gonna do it this way. Watch this. S adjust 1. Okay. S adjust 2. There we go. S adjust 1, S adjust 2. S adjust 1. Still works. That still works. What is going on? It doesn't like the employed. It's really mad about that variable. And that's all I changed. No, there's something wrong. Oh, because that variable's not included right now. So anyways, it wouldn't be there. Okay. What is it not like? Let me look at the data set. Yeah, Marjorie, we're going to class in 15 minutes, and I really want to make a really cool graphic. My goal here is to make a really cool display. I could just do the original data set, but I'm wondering what it's mad about. It's a dabble. I'm trying to think what dabble is. Dabble is, let me look at the other one. What is the other thing I've created? I've created a dabble there. That's a Tizble. Ooh, that's the problem. This one is a dabble, and the other is a Tizble. So the Tizble... So why is it creating... Do I have a typo? It's a dabble versus a Tizble. You're welcome, Kelton. This is for me right now. It's the problem. Okay, so let's go around this right here, and let's say as Tizble. So the problem is it doesn't like what I've done, and I'm going to say make that a... Ooh! There we go. So this is the original model. Oh, it didn't... Oh, then we've got it right here. So this is the graphic. Cool. So now we fixed it. Original model. Seasonally adjusted model. GG arrange. Do I still have it up? I do. P1, P2. And there you go. This is what I would have displayed to someone. So, Kelton, this is our original data model right there. The original, let's say, model data. So we just got it. We got it to work. Original data. And we can't go with that kind of orange. We got to do some UT orange, everyone here. So we got to go FF8200. And now we have UT orange. Slight change right there. Yeah, exactly. Way better seeing them side by side. And that's what we go for when we do visualizations, is we ask, what is a really good way to visualize this? That's not right there. Should start auto-changing. There we go. I hate that sometimes they get that little bit. But I would take this and screenshot it, and we can see the seasonally adjusted model, which removes out the seasonal component, and then we can see the original data. And what I would do, once again, is I would take and screenshot this to be exactly what I want, and maybe even use a little bit of, you know how I got that little bit of edge right there? Well, when I go into Microsoft Word and put it in my document, I'm going to zoom in right here, and I'm going to say, you know what? We're going to go to crop. There we go. That's about as best we can get on a picture. I do not like that the Jan says that, but that's we're gonna just have to deal with it, everyone, right there. But no, I like this right here. I'm always trying to make some good visualizations. This is what we talk about in 201 with chart titles, axis titles. We don't have data values on this. We saw some ways to do that yesterday, but this does communicate some ideas to someone, and we'd probably write a report of it down below. But this is basically what we're doing in Tool 1, and we do it in the upper level classes. With that, everybody, great work. Kelton, really good questions right here. What code do I need to use to see the slope of the simply linear regression model? Kelton, do you know the answer to that? How can we look at the slope of a simple linear regression model, which is a trend in your class? So how can we look at the slope of a simple linear regression model? How could we look at the slope? If we have a model, we can look at the summary. Oh, no worries, Kelton. I was just throwing out a question right there. John, great question. 100 points, John. If we want to look at the slope, we could look at the summary. Okay, right there. Good practice, Kelton. The summary right there, and that's the slope, and that's the estimate of the intercept. Good questions, John. There's the estimate of the intercept and the estimate of the slope. B0, B1, respectively. Their uncertainty, their t-statistic, and p-values here. We'll be back. We'll be doing some Tool 1 here in a moment. I'm going to go grab some snacks, and then we'll be back. More class coming up soon for Tool 1. See you then, everyone. Bye.